Hello guys, this is a video that I wanted to do um, to help you guys out with well, connections on coils. You got radios have coils in them. You have antenna coils. You've got oscillator coils. And of course you got like IFs, transformers, but we're not going to talk about that. The main things we're going to talk about is like oscillator and antenna coils. Now, worst case scenario, you have a radio and it's got a not very well wrote schematic, doesn't document the coils very well. It may, it gives you the basic wiring of them, showing that, if it's multiband, showing that they go to a switch. And it has their other schematic stuff connected to them, such as resistors and trimmer caps and so forth, but it doesn't really go any further than that. And let's say that you didn't take real good pictures when you tore into the radio. Maybe you got real good pictures of everything else of the radio, and you wasn't maybe at that time planning on pulling the coils out. You're just going to leave them in place. But then you get to looking a little closer at them. Maybe you was testing them or whatever, and you found a bad winding or something, or maybe you found, oh my gosh, there's a ton of rust down in there, and I'm going to need to get this whole assembly out so I can clean that rust up so it don't get any worse, or whatever reasons you pulled the coils out. But at the time when you did it, you wasn't thinking to take pictures. Well, what happens? How do you determine where those connections go? I mean, you got connections on them. Where do they go? There's probably some connections here, and you'll have some connections at the end of the coil, and maybe along the side, like I say on this one, and so forth. Where does the wires hook? What hooks to those? If I don't have any real good documentation, and as far as schematic, some schematics will actually show the coil. They'll number off, they'll go like 1, 2, 3, 4, and whatever. And you get, and they'll have something at one side and one end that they can establish that it's this side we're looking at, and not this side or this side or this side, but we're looking at the coil like this, and this is 1, this is 2, this is 3, and this is 4. But other schematics won't do that. So how do I know? How do you find out where everything hooks? Well, that's what we're going to try to do, and I'm going to try to do it as quick as possible. Try to keep this video as short as possible. Let's take these guys for example. In the future radio build, these are the coils for it. Now these are nice, and they're not really good examples, but I didn't have any better examples, because they actually got a couple tuning capacitors that are permanently mounted. Well, not permanently, but they're mounted on them, and which makes it kind of nice too, because if you actually have something like this and you pulled it out, that there is a nice piece of information right there alone, because those, I got the schematic up, represent that cap, that cap, that cap, and that cap. So C2, C3, C10, and C12. Those are these caps, like on this coil and this one. Now, on the schematic, antenna coil. Real easy to tell that's the antenna coil, because at least one end is going to an antenna. Okay, the other side goes into the grid, input grid, into the modulation oscillator, mixer oscillator, whatever you want to call it, converter oscillator. They've got several names. This over here, oscillator coils, they go back to the oscillator section. Now on these pentagrid tubes, generally this bottom section here, these three elements, and primarily these first two grids will be G1 and G2, are your oscillator circuit. that makes up a triode. This is what would be the plate. Even though it's a grid, it's a plate because it's got positive voltage on it and acts as a plate in that with that positive charge on there. This is your control grid for this lower section triode oscillator tube section. So anyway, how do I know this coil from this coil? You have to go back to radio theory. Super heterodyne radio. What the tube does, what this is doing here, is it pulls in a radio signal that you tune in, comes into the tube. When you tune that radio station in, you're also, second part of the gang condensers, tuning the local oscillator. That comes in. The two mix, and the difference of those two is the IF. Okay? I mean, there'll be 4 basic signals plus harmonics that comes out. But it's the difference between the local oscillator and whatever radio frequency that you're picking up makes up the IF. And that's what will get through the IF. So in this case, this radio runs at 455 kilohertz IF. So if this was set, say, at 1000, maybe you're picking up a radio station at 1000 on the dial, then the local oscillator would be running at 1455. 455 kilohertz higher than this. What that means is this is a higher frequency coil as opposed to this. That means this has less windings than this one does for the respective bands. That's how you tell the difference between your local oscillator coil and your antenna coil. Your antenna coil is going to have more windings. This end of the antenna coil represents the broadcast band. This is this end here. These coils represent the shortwave, and this actually goes up to about 18 megahertz. So anyway, on the broadcast band, you can see that that's got a lot more windings on it as opposed to the oscillator coil, which is the broadcast end. It has a lot less windings. So that's how you tell the difference. That's the number one thing, is to find the difference. The other thing is to start looking for common points. In any oscillator that is, well, the two ends, the two coils that make up the basic coils or transformers of the oscillator and the antenna coils. In any oscillator, no matter whether it's a Hartley or a Hartley or a Tickler coil or Armstrong, one end of those coils is going to go to a common neutral, more or less basically in the oscillator section. So you see here, this is the broadcast oscillator coil. One end here of the Tickler coil, less windings, goes here, the other end connects here. They go through a tuning cap and go to ground. But the main thing is they've got a connection right here. So you look for those common connections, and you can, you may have to look down through. It's going to be kind of hard probably to see some of the windings in there, wires in there. They may, a lot of these will run wires down through the tube. That's what you're looking for. Look where they make that common connection. Over here on the antenna coil, it's a little different. The primary and secondaries actually don't make contact, but the two secondaries, common point, ground. Two primaries, common point, and actually this is the AVC line, so that's what they're connecting to. Once you establish those common points, then the rest becomes a little simpler. Then you can take the other end, say the Tickler has to go back through the band switch back to the plate of the oscillator. This end, which is your tank circuit, here's your tuning condenser, has to go through the band switch back through to the tuning condenser, and then through your biasing circuitry, but back to the grid. On this side, opposite of the common points, these two ends will go back to the antenna through the band switch. These two ends opposite the common point go back through the band switch and go to the input grid, and also the tuning condenser. So that's one thing. But let's say, for example, you can find coils where you don't have that. There's no common points. The common points were made up outside the radio, or outside the coil. Not outside the radio, that'd be kind of silly. Outside the form. They weren't done on the coil form. And in cases like that, then what you have to do is you have to, what you should be doing even with these is document. And what I mean by document the coil, I did just a real crude, real fast drawing of one of the coils, which happens to be the antenna coil. And it should make a little better drawing than this. But you draw out the coil as it physically looks. Find your pin numbers, and you can either number the pins and put off to the side where they hook to, or you can do it like I did here, L3, L4, L2, L2 and L4 hooks here. The various tuning condensers, I got L3 and L5 here. L5 is in black, L4 is in red because it's actually underneath it. And where they all make connections to the various points on your coil form. You may have a coil form in a coil or multiple coils in a multiple band where, in cases like that, where each individual winding, in other words, like here, each end, this wire and this wire on each end of this coil goes to a terminal like this. Okay, so like in this case you'd have 1, 2, 3, 4, 5, 6, 7, 8. You could actually have 8 terminals that's on here. So what do you do then? Well, the easiest way to deal with that is, first and foremost, is I would deal with the oscillator coil first and then worry about the antenna coil after that. Secondly, if I got a multi-band radio, now if you got a single band, you don't have to do this because you only got one band. But when you got a multi-band radio, the thing I would do is I'd be concerned myself with the broadcast band only and do a temporary tack-in connections. And what I mean by that is, why you're going to do that. What you're going to do is you're going to look for this end and this end of your tickler coil, which will have less resistance and less windings. You'll visually see it. I mean, you can visually see right here that's that little dinky coil, is that L7 on the schematic. So this other one goes from here clear up underneath this one, so that's L6. So you can see the difference. You find the two ends of it, mark them out on your documentation that you're making of the coil. Then find these two ends of L6, do the same thing. Now remember back when I was talking about oscillator, that these guys has got to be out of phase with each other. The way you do that is which direction they're rotating around the form, you got to look at. So if I can get it stand up. Anyway, does it go around this way, or does it go around this way? So you have to document that too. You want these to hook up so they're opposite in their rotation around the coil form, so that gets them out of phase. So they have to be out of phase. L7, one end is going to go to the plate. The other end is going to go whatever, if there's a tuning condenser or a fixed capacitor, whatever, for a common point, it's going to hook to that and then eventually go to ground. And when you get to L6, the opposite end, in the opposite rotational direction, will go to the grid, and the other end you hook to that one end of L7 that goes to that capacitor and goes to ground. Your antenna coils are not as critical as oscillator coils. Sometimes they're made up so they're in phase, sometimes they're out of phase, but it doesn't make a whole lot of difference. One way will attenuate the signal, possibly attenuate it just slightly. The other way will allow it through better. Just go ahead and locate these two ends, locate these two ends, and make your connections. You can either make them in phase or out of phase. Just worry only about that broadcast. That's the band you know you can pick up radio signals on any time of the day. Once you get them tacked in, then fire up the radio and try it out. If it does not work, it's most likely here. So take and unsolder one of these coils, say maybe the tickler because they'll have the least amount of connections, and flip it and resolder it in, and then see if the radio works. In any case, once you get the radio working, let's say you flip it, now it works. Now you know that that's the direction it needs to be, what direction this one needs to be, and this one needs to be concerned with each other. Then you can wire these in the same way. Because these forms, they wind these forms at the same time. On the same machine, they just have multiple spools of wire for the different sizes. So they're not going to wind one way and wind, and then stop the machine, turn the form around, get another spool out, and wind it the other direction. They'll be all wound the same directions. So once you establish this, then you can establish the next band. And same with the antenna. Now the antenna, this is going to be more choice. It will work either way. But one way may sound better than the other one. One way may pick up signals better than the other. And it may not make any difference. You'll have to make the judgment call on that. The main one that will make a difference is the oscillator. So that's what you have to, what you'll have to worry about. That's when you don't have good documentation. Now, what do I mean by good documentation? Well, this radio here has got fairly excellent documentation. And what I mean by that is, okay, and this is one of the radios, one thing about this radio, instead of putting a lot of the bands on the same form, they use separate forms for each band. There's 5 bands, so they use separate forms. Here's the antenna coils. And you notice they got a little mark here that is establishing which way you look at the coil. Do you look at it this way, this way, this way, this way, what direction it's going to look. And then they establish, here's pin 1, here's pin 2. Well, if you come up and up, here's that coil right here at the very top. Pin 1, pin 2. So now you know that this comes up here, hooks here, hooks here, hooks here, goes to the band switch, which then goes to the grid. So same way on the next one. They've got 1, 3, 2, and 5, and they say it's a tap, and then 4. I'm telling you that's tapped off. We look here, it's kind of hard to see the 2, but they told you it's tapped. So there's 1, 2's tapped, so there's 2, there's 3, there's 4, and there's 5. Now you know where everybody hooks. That's decent documentation. But the thing is, even with this good of documentation, you can still make a mistake. So what you want to do is, the best way not to get into this situation of knowing where to hook up everything is make your own documentation. Even with good documentation, you might want to take pictures and make further drawings of each one of these coils. Always take pictures. Even if you're never going to pull the coil out, you don't know for sure, take pictures of it and document. It may have colored wires on it. Maybe this one had red and this one had blue. Well, then document that. Take pictures and then also write down and show the coil drawn out like I showed on the drawing here. And then you can say red wire goes here, call it pin 1, blue wire went to pin 2, and so on. But pictures, a lot of pictures, making your own drawing, mapping the coil out, which also helps you in establishing the coil's good. You know, you can measure it and check it and everything. Good, your own documentation, plus familiarity and the documentation of the schematic. You should know the schematic very well and know how to find everything that's on the schematic to the radio. So you should study it long before you ever pick up these guys, before you ever take anything out. Study the schematic, know where everything's at, and understand what they've documented in the coils. Make your own documentation, take your own pictures, do all this, and you will be less likely to ever get in any trouble of not knowing where to hook things up at. But if you do get in that trouble, then the first thing to do is establish which coil is which, and you tell that by the number of windings. Oscillator coil always has least number of windings on it for each band. Secondly, look for common points, if there's any. A lot of coils will have them. They won't be individualized out to the different windings where you have a whole bunch of points. Look for those common points. Look for other things that can help you, like these has got condensers on them, caps on them. And that'll help you where the windings hook up to, because you know that they hook up. You can find them in the schematic. They're labeled and everything. So once you get to that point, you find your common points, you know where they hook to, then the other points are a lot easier to locate, and you can locate those by just looking down through the coil, maybe taking some measurements and stuff. So I hope this kind of helps. If you still have further questions, I'll do a part 2 to this and go a little more in depth into it. One thing for sure is sometimes it's hard to see the wires in there, and the only piece of advice I got for you is if you can't see them, like there's wax in there or dirt in there, is gently and time-consumingly, real gently, try to clean it out. You can put these in an oven, but the oven cannot exceed 200 degrees, and I prefer not to exceed 150. The enamel on the wire can withstand 400 degrees when it was new. So the shellac that holds these in place can withstand up to 300 degrees when it was new. Only the wax melts at a much lower temperature. But you could set these in, get them so they'll stand up, put them in a cold oven, set it to its lowest setting. If your oven will go to 150, only set it to 150. No more than 200. And then let it heat up. When it actually gets past the preheat stage, when it gets to that maximum temperature and your preheat light goes off or whatever, 5-10 minutes later, 5 minutes later, shut it off, pull the coil out. Your wax should be at the very bottom, had drained down, and then you should be able to see the wires. Don't leave it in there very long. It can get rather dangerous if you do, because like I say, these are old. The enamel, everything on here is old, so do it at your own risk. Otherwise, try to map it out best you can. If it is dirty in there, you can use some various light duty cleaners and a soft brush, like the little acid brushes that is talked about a lot on YouTube, and gently clean it. Some of the wires that's in there, some are these heavy wire, you ain't gonna damage it, but some of it's real light, very small wire, so those could very easily pull loose. You in there messing around too much. But look for the common points. If there is no common points, if there's just individual connections, work with the oscillator first. Remember that tickler or primary coil has to be 180 degrees out of phase, which means the rotation of the wire will be different. In other words, your connections will be such that when the rotations will be backwards to each other, the way you connect it up. So remember the 180 out of phase with the primary or the secondary of the coil. And then only tack it in. And only deal with, if you got multi-band, only deal with the broadcast for the time being. Tack them in to, if you got it figured out which way they should hook, and get the rest of the radio done, and then fire it up and see if it works. If it works, you're good to go. You can finish off the rest of the coil form and the rest of the coils, get them all hooked up, everything permanently hooked up, and call it good. If it don't work, try flipping, say, the tickler coil. It'll probably be the easier one than the other one. But flip the connections on it and then try it again. And see, make sure it works then. So anyway, if you have any more questions, leave them in the comments. I can make a part 2 to this and stuff and go over it. As far as future videos, I'm working on the next math video, the next theory video. I haven't exactly sure what we're going to go over yet. And then plus I've got our signal tracer. We're getting close on it. It's went through a couple redesigns, and I'll go over it on its own video, what I ran into and where I'm at. So anyway, I'm about out of time on this card, and so I'm going to stop the video here and just thank you for watching and for your comments. I've been real busy. I'm sorry I haven't got back to answering some of them, and so I'll try to get better at that. Thanks for watching. See you on the next one.